Associated with the cerebellum would be a population of cerebellar nuclei. These cerebellar nuclei have efferent or outputs. And so we'll explore the nuclei and what their output is. Where are they going? What are they signaling? What is that circuit between them and another structure? The first nucleus to point out is the fastigial nucleus, and it's identified in this region, and we see it here on the opposite side. Output from the fastigial nucleus will be to the vestibular nucleus, that nucleus that will help control equilibrium or balance. We also have a collection of nuclei that I'm going to just call the interposed nucleus. There are 3 of them identified, here, here, and here. These are shown, at least 2 of them are shown over here on the opposite side. And then the third one that's not present in this oblique section would reside along here. The interposed nucleus connects to the red nucleus in the midbrain and also has connections to the reticular formation in the brain stem. The most prominent nucleus is the dentate nucleus. And you can see the irregular contour of this very large nucleus. And here it is on the opposite side. This projects to the thalamus, specifically the ventral anterior and ventral lateral thalamic nuclei. The cerebellum can also be defined functionally, and this functional definition is going to be by connections from these functional divisions. First is the vestibulocerebellum. The vestibulocerebellum would connect between the cerebellum and the vestibular nucleus. And the vestibulocerebellum is the flocculonodular lobe that we see here. The spinocerebellum is the connection between the cerebellum and the pathways in the spinal cord. This is occurring within the intermediate hemisphere. So the intermediate hemisphere represents the spinocerebellum. And then lastly, we have a connection between the cerebellum and the pons, and this constitutes the pontocerebellum. And this functional division is represented by the lateral hemisphere.